The naming system for organic compounds is called the IUPAC naming system, International Union of Pure and Applied Chemistry, hence IUPAC. Much nicer to say. All right, rule number 1. The longest unbranched carbon chain is the parent chain. So that's the major part of your name. That's always going to be at the very end of the full name. Anything extra is going to go in front. Rule number 2. You number the carbons. Okay? And so number carbons, because we have to figure out how many we have, of course, in order to name it. And then what you want to do is you want to give the direction. So, if we go back up here, how do we know how to name it? Do we go 1, 2, 3, 4, 1, 2, 3, 4? Okay. So you want to name it, giving it the direction so that your branches or your substitutions always have the lowest number. So they always have the lowest numbers possible. Again, this gives the location of those. So let's go back up to that sample that we had. Okay. So with this, you can number it 1, 2, 3, 4, or you can number it 1, 2, 3, 4. Now if I number it this way, my methyl group is off carbon 2. If I number it this way, 1, 2, 3, it's off carbon 3. That's a higher number, not the lowest number. So this would actually be called 2-methylbutane. Again, your longest chain was 4. There's your butane. My branch is a methyl group, and it's coming off the second carbon. So 2-methylbutane. All right, going back up. So that's the numbering system. Sometimes you'll have to actually write it out. Now, and that's how I knew that this was going to be the same thing. Because if I number this 1, 2, 3, 4 to give my methyl the smallest group, it has the exact same name. That's how I know it's not an isomer. Okay? Because they have the exact same name. It would have to get a different name if it was a true isomer. All right, next, rule number 3. Again, you might have more than one branch. When you're naming your branches, you want to make sure that you give the location using that number. So this is just a reflection of what we just said. Number your alkyl groups as part of their name. Okay, as part of their name. So we know where they're at, especially if we have more than one. All right, rule number 4, if you have more than one of the same kind of group, okay, more than one of the same alkyl group, you need to use prefixes. So let's say you have 2 methyl groups, then you're going to say dimethyl. Okay. But you still have to use rule number 4. Where are those 2 methyl groups? So you might have something that might go like 2, 3, dimethyl. Then it's telling you you have 2 methyl groups, one on carbon 2 and one on carbon 3. Okay, so you're going to use your prefixes. These are the same prefixes that we used in organic chemistry. Then they state rule number 5, which really we've kind of already covered. Rule number 5 just says that you do need again, it's kind of like rule number 3. You're going to need to attach a number to the alkyl group to indicate where it's at. I don't know why they repeated it, even if it has the prefix. So maybe they were trying to establish it goes number, then prefix, then your alkyl group name. Okay. Now when you do this, there's actually a dash here, a number, dash, prefix, and then the alkyl group. And this is all one name. And that will attach then to your chain name. Again, all one. So the 2,3-di, it could be 2,3-dimethyl hexane, all together. Okay, so all one word. So that's kind of rule 5, putting it all together. Now rule number 6 comes in and says, after that, your non-alkyl groups or halogens, because you can have other things attaching besides hydrocarbons, would then come in front of that, okay, along with locator numbers. So everything you have to tell them everything. Where is everything? All right, and then I'm going to squeeze in rule number 7 here at the bottom. Rule 7. Again, you might have 2 of the same alkyl group attached, or you might have 2 different alkyl groups, or maybe you have 2 alkyl groups and some halogens. How do you know where they go? Again, halogens first, then your alkyl groups. Sorry about that. And then when you're doing that, always alphabetical. So maybe you have a chlorine and bromine. Bromine would come first, then chlorine. If you have your alkyl groups, if you have an ethyl group and a methyl group, your ethyl would come before your methyl. Alphabetical order. All right, let's look at an example. We'll give you a complicated one so that you can see all of these rules coming together. So let's go with C, H, Cl, Cl, C, C, H. They get really, really tight, and so you have to look really, really close. I'm going to go give myself a little more room here. C, C, H, 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 H. Remember, always 4 lines coming off. Always, always, always. Go C, H. Oops, let's put another C here. H, H, H. C, H, H, and H. All right, so let's practice naming. So when you're doing this, you do have to be careful with branches, because sometimes you'll see what looks like a branch and it will actually be part of the longest chain. So you try for the longest chain. 1, 2, 3. That obviously would not be the longest chain when you can go farther. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you got different possibilities, but since this has 5 going across, I'm going to call that my main chain. Again, 5. We know that 5 is pent, so my parent is going to be at the end, and it's going to be called pentane. Okay. Next, I need to number it. Now, when I'm looking at this, I have chlorine. So remember, my chlorines are going to be called chloro. Oops, I've got my O. Okay, it's going to be called chloro. There are 2 of them, so I would have a dichloro. Next, I have, right here I have a methyl, and here I have a methyl. That's methane. So I have a dimethyl. If this is going to be my designated chain, I also have a branch here, and this is 2, so that's going to be an ethyl. So those are my branches. They're going to have to go into this name. But before I put them in the name, we know this would come first, so that's good. It would say dichloro, and then you have to go alphabetical. So your ethyl group is going to come first. You don't go by the prefix, you go by the actual name of the substance. So I know it's going to go dichloro, ethyl, and then dimethyl. So this one would be first in the name. This one would be second in the name. This one would be third in the name. Okay? And that's going to come in front of pentane. Now I need numbers, especially to indicate when I have more than one, I have to know where they are at. So we need to figure out what way we can do this. Now, if I can go 1, 2, 3, 4, 5, or I can go 1, 2, 3, 4, 5. Okay, so if we go to the top, I would have 1 dichloro. That would be a 1. I'd have a 2 and then a 4 for my methyl group, because you go 1, 2, there's my methyl, 3, 4, there's my other methyl, and my ethyl is off number 3. Okay, so that's one possibility. If I go the other way and start here, my methyls would be 4, or it would be 2 and 4, so I still would have 2 and 4, so that didn't change anything. My ethyl would be 3, but my chloros would be 5 and 5. Okay, that's not the lowest possibility, so I have to go with this one. Okay. Then you put it together. So my final name is going to be 1, 1 dash dichloro. Okay. And then you're going to put another dash. And then remember, ethyl alphabetically comes next. So that's going to be 3, and again, another dash, ethyl, and then a dash for the next part of the name, 2, 4, dash, dimethyl, and then you add pentane. Remember, the last part's all one word. That is the name of that structure. 1, 1, dash, dichloro, dash, 3, dash, ethyl, dash, 2, 4, dash, dimethylpentane. Typically, they just read it 1, 1, dichloro, 3, ethyl, 2, 4, dimethylpentane. Now, again, this structure was very complicated. It's something that you couldn't easily put together on the computer. You couldn't actually type it out very well. At least I couldn't. So sometimes they have what we call a condensed structural formula. So the way this one is drawn right now, if I were to go a condensed structural formula, I'd have Cl2, and then I'd go C, and I have my H. And so this indicates that this C right here is going to have an H off of it and 2 Cl's off of it. Then it's going to show my next one, and that would be CH. Okay, because this CH is bonded to this, but then I also have a CH3 branching off of this one. So that's going to be next. Oops, I got that reversed. It should be CH3CH, sorry. So this is going to this is going to this. Next, I've got my ethyl group coming off, so I'll have a C2, H5, okay, H5, attached to my CH, and then I have a methyl group, so then you're going to go CH3, and then a CH, and I'm running out of space, but my very last one is a CH3. Alright, so it gets a little bit crazy. As you're going through, you just always make sure that you have 4 things bonded to every carbon. All right, we'll practice a few more, starting with either with the actual structure formula or the condensed structural formula, and we'll practice on the next recording.